Hi, I'm Pierre Du Bois, founder of Zamana Analytics and contributor to IT Pro Today. And today I am going to explain to you how to EDA, Exploratory Data Analysis. Now, you've probably heard this phrase before if you played with data even a little bit. But in all honesty, it's not as complicated as it sounds. Most people think of it as data cleaning. What it really is data exploring. And what you're trying to do is explore with a particular data model in mind. So that means EDA has a number of applications. You may want to ingest data and have it within a simple table, just like you would for a spreadsheet. But you may also want to ingest data for a regression analysis where each column ends up being a variable and each one of those observations are contributing to that variable in the calculation. There's also clustering as well too. You may want to have each column and each observation being represented and ready for clustering analysis. And with regression and clustering analysis in mind, that means that machine learning is not too far behind as a purpose either. And one more as well too. With the advent of AI, there's also been the advent of vector databases. So now people are looking at how they can arrange their data to be formed into a model to be used for a vector database. So how do you EDA? Well, there's three particular concepts to keep in mind. There's a lot of different libraries and functions. We're going to use R programming today as an example, but many of these steps also apply to other avenues such as using Python. But the point of it is to ingest data, make adjustments to the data, and have a visualization put together and ready to go. So the first part, ingesting data, is pretty simple. It's just basically having data within a data object for your programming language. So that just means either using an API, or it could be something as simple as a CSV file and having that data being placed into a data object. The next step is thinking about the observations in the data set and trying to get a sense of what those observations are. And that's kind of a big part of EDA. The initial steps are usually looking at the dimensions and rows created. And what you're trying to do is look at the observations and see how many types of observations there are, whether they're characters, numeric, whether there are NAs in there, which means that there's observations not available, whether there are null variables or no observations in there in terms of missing observations. And then you have oddball text, and this becomes very important if you have a lot of text characters that will be used for some sort of text analysis, such as which is often used for clustering, sentiment analysis, and that type of investigation. So for our example, we're going to use R programming. I have R Studio right here in front of me, and we're going to use a very simple data set from the library GT called GT Cars. And I'm going to put it into a data object called Cars EDA. And to what I just described, we're going to take a look and see how many dimensions there are. And there's a couple of things you can do here that's very simple. I'm using the head function to give me the first 5 rows in my object. So as you can see right here, I have a data frame with a number of columns: manufacturer, vehicle model, the model year, the trim, body style, and so forth. And this only gives me a little glimpse of what's there, basically. If I wanted to look at the dimensions to figure out how large this is, I can just use the DIM function, which is built into R, to get a sense of how many rows and how many columns there are. And right now there are 47 rows of observations, 15 columns of observations, basically. So we have a 47 by 15 data object. Now, one part of this, if you notice, I only kind of got a very small glimpse of the first few rows, and then I got some information here that told me that there was more variables. And those variables means that are pretty much columns, and those more variables, I probably would want to see what's going on in there. So our basic functions, while they are helpful, they don't cover everything involved. So I turned to a couple of libraries to help me to dig into the EDA part. And this gets into these functions not only help expand what I see, but as I can show you, they will also show you how to look for NAs, nulls, and a lot of the observation behavior that I mentioned about earlier. So the first library I'm going to use is one that's very popular in R. It's called Dippler, and has a function called glimpse. And so to call it, I'm just basically calling this function glimpse and applying it to my data object. And you can see here, I get the same type of information. I got the number of rows, 47, number of columns, 15. But if you notice right here, it's giving me the names of those columns. So I have everything: manufacturer, model, year, trim, just like I had in that first example. But I also can see body style, horsepower, RPM, when the RPM is for that horsepower, peak horsepower, torque, the peak torque RPM, city miles per gallon, and so forth. And then you get a little bit of a preview of each one as well too. So you can kind of get a sense of, is this a numeric value that's being placed in these observations for a given column, or are they text like you see here for body style? So you kind of get a nice little view here, a little bit more than what you have from the basic. Another popular function and library, in fact, this library I would highly recommend, is called Fun Modeling. And it has two particularly really good functions built into it. The first is called df status. DF stands for data frame. So if I run this on my object, I now have a little bit more information. I have my variables, each one of the columns that we talked about before. You can kind of see a count for each one of these. So you can see each column in order, all the way down to 15. But then I have these first 4 columns. There's actually 3 here, and there's the other one right there. They are the quantity of zeros, percentage of zeros, so you have Q and P, and then you have quantity of NAs, and then you have, if I scroll down, the percentage of NAs. These are helpful in figuring out if there are any zeros or any NA values within each one of these columns, and it breaks it out into a table. So you can see here in this first row, this first variable, manufacturer, I have zeros, for lack of a better term, and then 0 NAs. But if we were to scroll down to torque, city, and highway, it looks like I have one NA in here for a quantity, or rather for a quantity. And if you look down here, I think we can see, we see a percentage right here. This number right here is 2.13, is saying that there's 2% of my values in these particular columns have NAs in them. There's also the same sort of structure for infinite values as well too. So these are kind of like the nulls that you might want to see. Tells you the character type that appears within the observation, so you get a sense of character and numeric, and which column those are in. So our first column is character, while our third column is numeric. And then you get a sense of what the number of unique values are involved here as well too. So that can be pretty handy. Now another function within Fun Modeling is called profile num. And if we run this, we now get a little bit more information. You see there's skewness and kurtosis. So, and I want to roll back here to the very beginning of it. You'll see not only the variable, but now the mean and the standard deviation. So between the mean, standard deviation, kurtosis, and skewness, you're starting to get a sense of the distribution of the data within each one of those columns. So you kind of get a really good view of what's going on here. And if you notice, it's some of these, some of these are a little bit more, may not make a whole lot of intuitive sense. Like you have year here. Obviously, you're not going to have the average of the year, so to speak. But average horsepower and torque does make a sense if you have a data set full of automobiles. And again, the standard deviation might be of help as well too, to give you a sense of what the distribution is. Same thing for MSRP. But it does leave, all these are each, if you notice, it focuses only on the numeric columns, the numeric variables, not the ones where there's a character, because obviously a character would not have a mean, standard deviation, and kurtosis, and so forth. Nothing statistical. Okay. And then, of course, you have range here as well, too. So that gives you some information as well, too. So profiling num is just basically the numeric data. So we looked at Dippler, we looked at Fun Modeling. Now we're going to look at another library and function called skim from the library skimmer. And this gives us similar information that we talked about before, and it probably covers quite a bit, basically. You get the sense of the numbers of rows and columns, again, 4715, the number of column types, if there's character or numeric. Now, group variables, this can be no or yes, depending upon how your data is organized. But I'll show you there is a way of setting up group variables within your data set for analysis. And then you get some details on each one of the variable types, whether it's character, whether it's numeric, and it's broken into two groups basically. So it's very similar to the previous functions, but it gives you a lot of good statistical information. And then finally, I'm going to scroll down here to the end. You do have a histogram that kind of gives a sense of the distribution for the variables that are numeric. So between fund modeling and skimmer, you have a number of options to EDA very easily. And then once you've done all this exploration, the third and final step is to make adjustments in your data. And those adjustments are going to depend upon what you're seeing in that exploration. Do you have a lot of NAs that need to be addressed? How would you address those things? Having that information makes it very helpful to understand your workflow and then make some decisions on how you want to address those things. If I want to, say, work on only the Ferraris within my data set, I can use the slice function within Dippler, for example, to call up that data and then get a sense of, put that into a separate object and be able to do some analysis. Or if I want the cars where the miles per gallon were above a certain value, 19, I can also use my filter function within Dippler to get all the values within the data set where the city mileage is above 19 miles per gallon. And that also can help me in terms of narrowing down my data set. But beyond slicing and filtering, you can also do some grouping as well too. Here's a neat trick taken from the skimmer library. You can combine libraries and functions to pull together groups of data. So for example here, if I want to do something by country, I can take the cars EDA, apply a pipe, then apply the group by function within Dippler, and it's going to group the data by city, by country origin, and then apply our skim function from the skimmer. So if I run this, what I end up with is the same output that you saw earlier with skim, but if I scroll up, let's see here we go. You can see that it's giving a lot of information based on the country origin. So I have my numeric is broken down by country as well as by the numeric variables. This gives me all my information that I can kind of narrow it down a little bit to maybe a particular country if I want to. Now, once I've done all this sort of adjustment based off of how I explored, now it's reporting time. And there's a number of ways you can do this. There's no one right way to, just like there's no one right way to eat a Reese's Pieces, there's no one right way to do EDA. So you can craft a report. You can use Quattro, which is kind of like Markdown, basically. Or you can look at a library within R or Python to visualize all this information. Fortunately for R, there's a really good one called Data Explorer. I'm going to go ahead and run that. And it has a particular function called Create Report. So if I run it on my data object, cars EDA, you can see it's processing. And now what it does is that it gives me a report. This is very similar to what you see in Skimmer. But it's much more visual. You can see here you get the number of rows and columns. That's always very popular, obviously. But it gives you discrete columns, continuous columns, complete rows, total number of observations, a sense of the memory allocation. That might be helpful if you're trying to figure out how large the data set is. So a lot of this deals with data set size. And then you have some visualizations here. And I won't go through all of these. Some of these are a little bit intuitive, some of these not quite so. But what this does do, it gives you a report as an HTML that you can now load into a cloud server or send to someone for their input. Missing data profile, giving you a sense of where there's missing data. Here's those three column values: highway, city, and torque. 2.13% are missing in the rows. And to be honest with you, it's because one of the vehicles is a Tesla. So it's an electric vehicle. So there's missing information there. But that also speaks to another point about EDA. Know your data. Know what types of observations you have, and that can help you interpret or at least get a sense of what's going on in that data set that will help you in your workflow. Histograms, bar charts with frequencies. The two that are interesting, I'll call these out very quickly. Correlation analysis. This goes across pretty much just about every category. But it's useful for kind of getting a sense for features and for principal component analysis, which types of columns may be correlating heavily together. And this is a little bit more elaborate than normal because we haven't quite said it, but the point is you have that available to you. And then you get also a visual for principal component analysis, what might be, what percentage of the variance is explained. But the point of this is that you have a number of visualizations that you can now go back and make adjustments in your EDA. So what have we learned here? So for EDA, the thing that we have to keep in mind is we ingest our data. That could be, again, API or a CSV file, maybe even Excel files or what have you, but put it into a data object. Get a sense of what the dimensions are in terms of rows and columns. And then look for functions that will help you identify, at least statistically among numeric data and statistically among the character data, some sense of what's going on in that data set. How many NAs, nulls, or special characters are appearing. Once you have a sense of that, you can then get a sense of how you want to slice, dice, how you want to explore the data maybe further, and arrange it such that you can finally get a sense of data that can be placed into an object that can be carried over to the next level of modeling and analysis. Keep these things in mind, and I can assure you that your workflow will flow very smoothly. Take care for now.